Okay, I think we're ready to start. So I'm here to tell you about Scala and how to use it in Spring application. I'll show you a couple of examples of interesting things that you can do with Scala, and hopefully they'll give you enough motivation to give it a go. It's not difficult, and the rumors of Scala being far too complicated for anyone to understand are completely false. It's actually quite simple, and you'll see as we go through the talk. So, come on. Okay. Right, I'll just press the button. So my name is Jan Machacek. I'm the technical director at Cake Solutions. I've written ProSpring 2.5, and a couple of other books and articles. I've contributed to Spring extensions, the workflow extension, which is now far too old for anyone to seriously consider. There are far better ways of doing what the extension does now, but it's out there. I've written Specs to Spring, which is a behavior-driven development testing framework for the Spring framework, using Specs 2, which is a Scala testing library, and we'll see examples throughout the talk. I had a go at writing pure Scala data access code in Scala. By all means, have a look. They're all open source projects. You'll have the URLs at the end of the talk. And I've done a little Spring extension to Spock back in the days when I thought Groovy was really cool. I still think Groovy is really nice, but it's not as brilliant as Scala. And I edited the open source journal, which is a UK-based journal. So if you want to get published, by all means, send me an article. Starting from 2 pages, even 1 page. And we publish, I think, 20,000 copies, hard copies, they're physical things. And we send them out all over the world, so that might be an interesting start of your writing career. And then it goes downhill from there. It's just months and months of work. So, what is Scala? It is an object-oriented language. So it's comfortable. It's just like Java. If you want to ignore everything, all the functional and type-safe things that Scala brings, you can treat it as a pure object-oriented language. Interestingly and quite beneficially, everything in Scala is an object. So even true and one are objects, and we call methods on those objects. So something you might find comfortable with Groovy. We also get mixin composition in Scala, and that feels like a multiple implementation inheritance. So if you ever wanted to mix in, have multiple traits, multiple things that implement pieces of functionality and compose them into a larger unit, into an object that you want to use, then mixin composition is really brilliantly helpful. Again, we'll see examples throughout the talk. Now, Scala obviously is a functional language, so you get all the functional programming constructs. Function is also a value. And because it's a value, it can be bound to a variable and given as an argument of a function, or even returned from a function. You get static typing and pattern matching and type inference in Scala, which makes it really, really easy and really, really powerful to build complicated and rich type systems. So a lot of the behavior in your programs you can model within the types, which again, you'll see it can be quite helpful. And finally, I think at this moment, the most beneficial, the most interesting point is that it compiles into Java bytecode, and of course it can read and understand Java bytecode. So if you want to use Scala, all you have to do is write about, 10 lines of XML in your Maven file. And that's it, that's all you have to do. And from that moment on, you can start slowly adding Scala to your projects. So it's really, really easy to begin. You can use it for, anything. So all the way from these fantastically complicated aspects and portions of your code, where your task is to implement a rich type system. Rob yesterday was mentioning something about quote and risk calculating engine that he's had to go at in Haskell. We had a chat with him, and it would have been just as easily possible to do the same work in Scala. He actually ended up doing it in Ruby, but that's by the by. It is the Java of the future. You get functions, you get traits, you get pattern matching, you get type inference, and it runs just as fast as Java. If you look at the compiled code that the Scala compiler produces, it's just as good as Java. So there won't be any sacrifices to speed. Now, you can also use Scala to implement, I say, the ordinary code, the day-to-day stuff. If you're writing your Spring controllers in Spring MVC, do them in Scala. You'll benefit from, well, you won't have to write semicolons. You can skip the word public. And the whole thing is just shorter with a lot less syntactical noise. So you might find that quite helpful and useful. And you can also use the various implicit conversions in Scala to build type-safe DSLs. Portion of your code that would be from a domain-specific language, it's really, really easy to do that in Scala. So everything applies. Now, just as a bit of a recap, what is Spring? I'm sure you all know it, but it is a dependency injection container at its core, and then it adds AOP, internationalization, and then ORM, JMS, JXM. I checked with Rob and Adrian, it's not those two. But other than that, everything else is included in the Spring framework. And it's done very cleverly. It's done unobtrusively, which means that the code that you write, your Spring applications, they're just plain Java classes with a couple of annotations if you want to use them, but plain old Java code. And Spring cares about the bytecode. It uses reflection to examine what is it that's running, what are the annotations on the types, and it then uses reflection to call the setters and the constructors, which means that it will quite happily use Scala. In fact, here's a little Spring application, bit of Java, public class dependency, which is a component, and then that gets constructor injected and setter injected. So this is familiar Spring code, nothing fancy about that. And it works just the same in Scala. The only difference is ever so slightly different syntax. Simplified syntax, I'd say. We don't have to say public, so we save a bit of typing. Constructor is defined here just after the name of the class before the opening curly bracket, and that also defines the field. And it is also auto-wired, and then we have a setter for the dependency. So it's the same kind of code. If you want to start using Scala, you can write code that looks just like that, avoiding all the complexities of Scala. I'd urge you to actually look into it deeper, because Spring, of course, doesn't care that our code is in Scala. So should we care? I'd say yes. And I'm going to show you a three-phase plan to get your code running in Scala. It sort of goes like this. Actually, not quite like this. We'll skip the phase one. We'll end up with profit. So all I need to show you is what are these phases. So in phase one, you might want to start writing plain old Scala code. Just take advantage of the simplified syntax. Don't worry about semicolons. That might help you. And phase three is profits. Phase two, that's the difficult one. That's when you need to learn to fully use all the Scala features to write elegant and type-safe code. So it's the experience that you'll get with using Scala, and that will allow you to write some fantastically easy and fantastically understandable code, but very powerful at the same time. So we'll take a look at three important concepts that Scala brings. I won't bother you with the classes, that's easy. We've all done object-oriented programming to death. We'll take a look at functions, and then types, and then type variables, type systems. So, just like in mathematics, a function, I have a thing called f that goes from a real number to a real number. So that is like a definition, a type of f. I do the same thing in Scala. If you see here, there's another f, which is a function. And I say we go from a double to a double. So that's the type of this variable called f. And its value, well, just like in maths, it actually computes a square of the parameter given to that function. So I write that. I take that x, which is the parameter given to the function, and it returns x times x. So that's quite helpful, but there's a lot of syntactical noise around it. I can simplify it. Or rather, I can take advantage of Scala's type inference. I can actually just write that. Now, why is it enough? Well, it's because we can look at it, we can understand it as humans, so why shouldn't the compiler? It's because x is double, that's what I say here. So the type of the parameter that the function expects is doubled. Now, double times double is another double. So it is pretty obvious that the type of f, even though I didn't specify it, it is actually inferred to be double to double. This happens at compile time. So this is not a runtime job. The compiler works it out and then checks that wherever you use this function f, you're supplying it the right types as the arguments. Now, of course, I can take a double number and call the function, apply it to that number 42. So, 42 squared is 1,700. Well, take my word for it. It's that much. Now, because function is a value, I can have functions that produce functions, and I can have functions that accept functions as their parameters. So, starting with a really simple one. So, it's a function that simply doubles the number given to it. I've skipped the type, but the type of the first function would be int to int. Int has a parameter, and it returns an int. And then I have this function, this second one, it's called twice. And it simply applies this function given to it as a parameter 2 times, starting with some number n. And then I have a third function that returns a function. So these two, twice and multiple, would be called higher order functions. They're functions that take functions as parameters, or functions that return other functions. So let's use them. I mean, this is obvious. Doubling number 2 is number 4. How about this one? Well, I'm going to apply the function double to number 2. So here's what's going to happen. Double is the way to evaluate f of 2. So double of 2, that's 4. And I'll double that again. And of course, I'll get 8. This thing, think of this function as a factory of functions, if you want to use the Spring terminology. But it's a function that returns a function. So here's what we have. Multiple returns a function that takes a number as a parameter. And it returns a function that takes another number as its parameter. And it simply multiplies the two numbers together. So applying twice function multiple 3 to number 2 is 3 times 2 here, that's 6. That times 3 is obviously 18. Now you might be thinking, why are we talking about real numbers and what's so interesting about it? But just humor me one last time. Does anyone know what that would be? Particularly English speakers in the room. No? You'd probably need a calculator to work it out. Now, if I turn it upside down, and so on and so forth, you can try it out. Enough. Let's do something a bit more serious. Another application of functions. So let's imagine I have a test, and I want to set up some test data. So I have an entity here called user with ID, version, age, first name, last name. So this looks like a thing that would be persisted in a database, maybe with Hibernate. And then I've written this. Now looking at it, we all here as humans, we sort of get what should happen. I'd like to have 2 instances of these objects created and their properties set. So how is it going to happen? What can we do? Mind you, this is real Scala code. This isn't just pseudocode. This is what we can write today. So let's see what we will do. First, there is a function called pipe greater than. So sort of send to it. You can choose any name of the function. And what I would like to do, being a test, is create an instance of a class represented by the row, set its properties, and then apply some function, the body of my test, that returns a result. Is it a success or is it a failure? Just out of interest, the definition of the function pipe greater than looks like this. We'll find out exactly what all these details are, but what you can see is that it's a higher order function because it expects another function as its parameter. This f goes from b, which we'll find out in a minute what it is, into a result. So, okay, well, let's give it that function. It's a function that goes from a user, that's the kind of thing we will be creating, into a result. Now, success is a kind of result. And just for good measure, let's print it out. Except this isn't really testing anything, is it? It's just sort of printing out these user objects. Maybe it's testing, well, it isn't testing anything. I just see stuff on the standard output. So let's wrap it in some real code that will turn it into a bit more meaningful specification. This is the Specs2 Spring project I was talking about. And an example, say for DSL, domain-specific language that you can write, which is implemented by in here, in the bean tables. But let's not worry about that for now. Let's write something, the name suggests we are testing that insert works. So we will probably want to be using, I guess, Hibernate. And this is comfortable territory now. It's auto-wired session factory. Now, if you're seasoned Spring developers, you'll probably have a guess as to where this session factory comes from. It's some sort of Spring configuration file. So this looks just like your normal Spring integration test. Context configuration, so we load a Spring application context behind the scenes, and then Specs2 Spring injects the dependencies into my test. This is fairly normal code. Auto-wired works just as usual. And I'll modify the function. And instead of print line, I'll say session factory save or update. And you might be thinking, well, this is quite useful. Now I can construct these objects, create the domain classes that I have, set their properties, and then save them. Except this bit of code, you'll probably repeat it over and over in your tests. We're talking about users here, but then you have another test that verifies that the reports can be inserted, and so on and so forth. So maybe we'd like to replace it with something. And that something is a function defined in Hibernate data access. So we can bring in a bit more functionality. We combine the traits together. This is the composition mix and inheritance that you can see. And instead of writing all of this stuff, we will simply call the function insert and give it the session factory. The function insert is defined as a thing that returns a function that goes from some entity to a result, which matches precisely the code I had before, except now it's returned from another function. Now there's this odd thing that says implicit. So what I would expect here is that the compiler would somehow implicitly specify or pass in the value that is the session factory. But I say it here explicitly. Well, if I really want to use it, if I want to write even fewer characters, fewer lines of code, I'd have to give the compiler a hint that this field here is eligible to be used in an implicit parameter. So I say implicit. And then I can forget that. And this is the real code. So if you're ever needing to set up some objects for your tests, you can use Specs2 Spring in Scala and write that. This is a nice application of functions and higher order functions. So we don't have to just be multiplying numbers. That's nice. It's nice to demonstrate what's happening. But this is actually quite useful. Okay. So the next thing that we're slowly heading towards are the type systems. Next question was, of course, what are these square bracket Bs and how does it all work together? So let's sort of rewind a couple of steps back and work out how the type inference works and what the compiler does. And remember, it's the compiler that does it. This isn't runtime. So let's see. The function type greater than is taking B as a type variable. So B, and then I have a function that goes from some B to result. Now in my case, what I've written is B is a user. So in this particular scenario, the type B here would be bound to the type user. So if you imagine, it's sort of like saying greater than, or pipe greater than, F user to result. Now, quite helpfully, and this is a really, really cool thing about Scala, the compiler will implicitly if I ask for it, but it will give me a class manifest of the type B, which means that I can create instances of that B. That you couldn't do with Java generics. Well, you could, but there's a horrible hacky way of discovering what is the generic parameter. In Scala, there is no need to resort to hacking. It's done by the compiler, provided by the compiler for you. So in this function, that actually concatenates, applies this function f to every row, and then produces a single result, we can find out what the type was and actually create an instance of, in this case, user. So the last thing that we'll look at with these functions is this thing, which is slightly unusual. So the code that you've seen until now is reasonably comfortable. This might get a bit crazy, might a bit more difficult. It's not. You would probably be writing that in your Java code explicitly using some for loops and while loops, but we can do that, again, using higher order functions in Scala. So what do we want? We want to collapse, we want to create an object for every row, apply the function to every object, and then collect the results, all of those results. We'll have one result for every row, and we want an overall result for the test. So here's how we go about it. We start with these rows, and we map them using this first function, this light blue block. Because we call the function f given to us, that operates on every instance that we created on the line before, we get another list of results. So from rows, we go to results. So imagine for now that the function f returns success for the first row and failure for the second row. But if this is a test, we want just one overall result. Having two or many, that's not really useful. So we then need to somehow collapse them, fold them into one. And that's what this second thing does. So, how do we go about folding it? Well, this looks like a function that takes two parameters and returns, collapses the two parameters into one. So let's see how it works. We start off with some initial value. I'll call it success. So I'll be good and I'll pretend that it might just work. So success. That's the initial value given to the fold. And then the fold will pick the first value, first element of that list, success. And it's going to call this sort of orangey function. And it's going to supply the initial value and the first element of the list as R1 and R2, like so. Now the function calculates result 1 and result 2, so let's not worry too much about what that does. Let's sort of apply common sense and say that success and success gives a success. So that's what that does. That's the return value. But there's one more element to go. So the fold will reset, will move on to the next element, and it will take the current running result plus the next item in the sequence. And it's going to apply the same function to those two parameters. So result 1, the running value, plus the next element, and that will give us a result. So the overall result of this test, this particular test, is of course a failure. And we say because we had one failing, the whole thing failed. So what is the type, return type of this function? Well, we can work it out really, really easily. Look at that, because f is a function that goes from some b to result. This block here is now a sequence of results. It's guaranteed to have just results. So sequence of results. Now folding results gives us just one result. Again, necessarily true and enforced and verified by the compiler. And because this is the last statement in the function type greater than, the whole function, its result type is a result. Notice that I never had to specify it. The compiler worked it out for me. I could have given the type annotations if I really felt like it. But as you write your code, you'll discover that this is actually very, very useful. It doesn't mean if you miss out the type annotation, it doesn't mean dynamically type. It doesn't mean let's find out at runtime. You're saying to the compiler, work it out when you're compiling it. Okay, moving on to the next thing that might be interesting, particularly to Spring developers. Functions you can use quite nicely, particularly say for tests. And the folds and maps might be really useful for some of the business logic that you have. Composition is a way to get the required functionality in your code. So in object-oriented programming, or in Java, in Spring particularly, we compose instances of objects. In Scala, we'll have something slightly different, and I'll show you how to combine the two. But to begin with, if we have traits, now you can think of traits as interfaces with default implementation. So imagine in Java if you could define an interface and a method inside that interface, and if you could give a body. That's sort of what trait is. And you can compose multiple traits together to get the desired functionality. You can either bring in these traits in new classes, or you can use them anonymously. We'll see an example just in a moment. So trait, just like an interface, it can define functions. But it can also define function bodies, and it can also define fields. And you can then mix in as many traits as you want into your classes. And this will indeed feel almost like multiple inheritance. There are some rules that you can't break, so it's not free for all like C++. But it's actually quite useful. So let's see. We've already seen it, actually. You've seen it here. This was an example of composition. The insert method is defined in the Hibernate data access trait. And I've mixed it, composed it, I've inherited it, if you like, into this type, into my specification. Bean tables, well, that deals with this domain-specific language. And again, I've brought it in and decide what I want. So this can help me think about what kind of functions I define in my components. If I define them as traits, I can have traits that have 2 functions in them, that's all. And then I compose them to arrive at something that's really useful in terms of the application that I'm writing. Well, let's take another example. We are going to have a password codec and a notifier, and then we'll implement it. So this feels just like your ordinary Java code. I say here pure trait, meaning it only has definitions of the functions. There is no body of anything. So this, in bytecode, will actually be compiled down to an interface. And then I implement it. So this is what we would do in Java. And define a class, I say some sort of hashing password encoder, and then plain password encoder. And for notifications, we'll have emails and text messages. And then in a typical Spring application, you would use them Spring beans, so you'd pick one to be a Spring bean, or all of them, if you like, and you would inject the appropriate one into your user service. But you'd be injecting instances of, in this case, say, email notifier plus the plain password codec. You'd make those 2 objects, you'd make their instances, and then you would create an instance of the default user service and inject them into that. In Scala, we have another option, another way of composing functionality. And it looks like this. Instead of defining these SHA1 password codec and plain password codec and so on, the notifiers, I'll keep them as traits, which means that I can mix in their functionality into anything I like. I'm not going to create instances of these traits. I'll mix them into components that I'm creating. So let's take a look at our Scala-based user service. Instead of injecting instances of user password codec and email and notifier, I'm going to require the functionality or the functions from password codec and notifier to be present. So let's see how it looks like in code. These traits, pretty obvious. There's nothing too funky about them. These are the two interfaces or pure traits in Java speak, if you like. And here are the sub-traits, but with implementations. I've actually given bodies of these functions. Okay, so now I can mix them in. Here's how it looks like. I define a user service with a constructor that takes a parameter of type session factory. And look, at transactional, so I'm not running away from Spring. This is still load time weaved code. It's perfectly fine, or it can be a proxy. I don't have to break everything and forget everything I know. But this is interesting. This :password codec with notifier. This is in Scala, what's called in Scala self-type annotation. So what I'm saying is that when I create an instance of this, we'll need to mix in the bit. So let's see what that's going to look like. Now, of course, just to make it absolutely clear, the encode method is this one here, in password codec that I decide to mix in. And the registered method is a method defined in the notifier component. Now, let's create an instance of it. This one doesn't work. If I try to compile that code, it will get rejected. And the compiler will say, it's not enough. Because I say here that to make an instance of user service, I need to mix in password codec with notifier. Well, I'm not doing that here. So this will get rejected. I haven't satisfied the dependencies. So if you like to imagine these as compile time dependencies, that might help. These two obviously aren't enough. I've missed one of the two traits. These two, they're absolutely fine. So this particular instance will use the plain password codec with, let's say, email service. Oh no, SMS service. And this one will use the hashing password codec with email service. Now this is great, except how to use these in Spring. If I try to define a bean of class user service, Spring would effectively try to call that. And that cannot work. So you have two approaches. One, you can either use the Spring Scala namespace, which will be available in the next few days. Just need to finish a few last hacky things on it, but it should be ready for QCon. And you can write code that looks like this. I can define a bean, a Scala bean, whose class is user service. So this is just like the old Spring bean. Give a constructor arg, no surprises. And this is interesting. I can then mix in any traits that I like. And I actually support spell expressions here as well. So if the current environment is live, then I want to hash the passwords. So I will mix in the SHNA1 password codec. If I'm not live, so I'm probably hacking on it on my computer, I want to see just the plain, use just the plain password codec. And in both cases, I will mix in the email notifier trait. If you can't wait, if you really, really, really want to use it right now, why don't you use Java configuration? And you can do that. So this is usual stuff. It's exactly what we saw yesterday and throughout your Spring code. This is add configuration. We've enabled transaction management. I have the session factory injected it, so I guess I've defined it in XML. I evaluate this spell expression to give me the value of the profile, and then I have a function with the bean annotation. So whatever this thing returns is going to become a Spring bean. And just like the code with the spell expressions you saw on the previous slide, if the profile is live, then I will use, actually here's a funny little bug, I'd actually be not live. But it doesn't matter. Let's suppose our live environment uses plain hashes, and our testing environment, I'm that good, I can crack the hashes on the fly, does that. And then this is the rest of your Spring configuration. So again, I'm not suggesting that you abandon everything that you've learned about Spring Framework. You can very easily use it. And you can then decide to use some of the features of Scala that might be helpful to you. Oh, one last thing, of course, you may have noticed the title misapplication of the cake pattern is sometimes called the bakery of doom. Of course, it won't be your case. So let's keep going. Let's look at the final thing, which will be type systems and type variables. Things that you can do in Scala that are impossible to do in the likes of Java and Groovy. All right, so as a reminder, we write statically typed code, and the compiler verifies and checks the types throughout our systems. And Scala, through the mixing composition, makes it really easy to build these complex systems of types because I can pick functionality that I want in my classes. And you might have noticed this generics-like syntax. So I had sequence of results. You could have list of integers and map of, I have that string to my class, and so on and so forth. Except in Scala, these things aren't generic types, they're type variables. And they change, as we've seen in the mapping that goes, the function that goes from B to result. The B is a type variable. And we use square brackets. We can use the slightly awkward syntax greater than colon, and less than colon, and less than % as extends. So superbound, is it a class that extends one? Lower bound and upper bound is this one, and view bound is the last one. Don't worry about the view bound just yet. I won't go into the details, but have a look at what it means. It has to do with implicit convergence. We can even require just functions to be present. So this will show all the Groovy people how cool we can be in our statically typed system. And even better, we can specify type variants. So we can specify covariance, neutral variance, and contravariance on our types. So let's take a look at an example. This is a typical Java-like code, isn't it? I have an interface or a pure trait, which is called getter-like. So I'm saying that there should be a method called get. It's a sequence of some type E. And then I have two implementations of that trait, a hard-coded source and random source. They both implement getter-like of ints. Getter-like of int, which means that I have to implement the get method. In the hard-coded one, I simply return whatever I've specified as a parameter, as a constructor parameter. In the random one, I, generate random ones, as many as I want. And let's then have a function that sums all these numbers. So what I want is to give it a get-like, a sequence of numbers, or a thing that produces a sequence of numbers, and what I would like is a sum of those numbers. Okay, so this should be fairly easy. This takes a getter-like of ints, and it simply says source.get, returning a sequence of integers, and then sum. So in this case, I can call sum all of hard-coded source, giving a list that contains numbers 1, 2, 3, 4, and so on. Sum of that is 45. And I have another application that uses the random source. So 10 random numbers, in that case, with minus 400, 500,000. Now, okay. But any object that contains function get that returns a sequence of integers. And then the source is S. That thing that contains a function called get that returns a sequence of integers. So I can call it in exactly the same way. And of course, apply it and use it in exactly the same way. But I managed to get rid of the getter-like trait. If I don't even want to see the type, I just see here this awkward definition. I can also say that source is a thing that contains the get method. So, if ever you talk to the various dynamic programming people, dynamic languages people who say, all you have to assume is that this source has the method get. Well, we can assume, but we can get the compiler to check it for us. So, with a bit of trolling, actually, this was supposed to say Ruby, but oh well. Right, final thing, we can use Scala to inject or implement this common sense knowledge, encode common sense in our type system. So this is a trivial application that deals with animals. So let's take a look at it. These first 4 lines are simple. I have an abstract class food with no body. So this is a complete class definition. I just have a name. And then I have cat food, luxury cat food, and dog food. So this is a typical object-oriented programming introduction thing. Okay, so let's have animals. And this is the interesting bit. This is something I can do in Scala that I can't do anywhere else. So what I'm saying is that the abstract class animal has an abstract type, food, suitable food. It's called suitable food. And I'm saying that that type, when it's implemented, is still an abstract type. I never assigned it to anything. That needs to be a subtype of food. So obviously, and this is, I'm explicitly expressing the common sense that we've encoded in our names. It's pretty obvious that cat will eat cat food, and you can all see it. But I can get the compiler to see it as well. So what I can say is that class cat, which is a kind of animal, suitable food for cat is cat food. And that works because cat food is a subtype of food, as we see here. And cat extends animal, so it can specify suitable food. And then I have a subtype of cat, talking cat, completely made up thing. Now, let's feed these animals. And this is another interesting thing. So I have a class feeder, and it has a function called feed. And we're going to be feeding some food to some animal. But we will want the compiler to check that I'm giving suitable food to the animal, to the instance of animal that I'm feeding. So let's work this out. A, so type variable A is a subtype of animal. Okay, so far so good. So A can be cat or dog or talking cat or dog if I choose to have a dog. Great. F is another type variable which needs to be a subtype of A's suitable food. So whatever suitable food I have in type variable A, with this thing, I can actually prove that it is correct, that I'm not sort of messing up the types. So that was the whole discussion with Rob's risk calculating engine. We needed to check that we're giving the right types in. It's greatly simplified to deal with cats and food for cats and dogs, but it's still quite interesting. All right, so one more minute. Now that you know, now that you've seen glimpses of Scala, what it can do, so you've seen functions, you've seen how you can use it with Spex2 Spring if you like to test behavior of your Spring applications. You might want to try and use it in your tests. And it's really surprisingly easy. If you're using traditional Spring apps with Maven, all you have to do is bring in a few lines of XML that will turn on, so to speak, the Scala compiler in your projects. And you can then cross-compile and mix in Java with Scala in your projects very, very easily. The only term and condition that applies is that the Java compiler runs first. So you can use everything that you've written in Java from your Scala code, not the other way around, within one module. So as long as you remember that, you'll be safe. And then you can start using Scala beans in Spring. You can focus on the simpler syntax, nothing else. Write fewer lines of code. Then you can try and apply some of the advanced concepts in Scala. Maybe you want to use testing. So you might look at using all these higher order functions in Spex2 Spring to test your code. And then if you're really, really interested, you could look at other libraries in Scala, like Scalas and Shapeless, that bring in a lot of the computer science things. And you could then really wear your white coat to work and say, I'm a scientist, step away. You might consider mixing composition. What I actually found really, really helpful is to start with tests. You can sneak in Scala completely under the radar. I've seen many organizations that come in and they say, oh, we can't possibly use Scala in production. We don't trust it. So you say, okay, fine. don't worry. And you write tests in Scala, they never hit production. And before you know it, people have learned how to use it, and they will start really pushing what Scala can do, and they might even convince the rest of the company to use Scala, who knows? So in summary, Scala is a statically typed object functional language, which some people find absolutely shocking, but it's actually quite useful. It is scalable because it allows us to deal with complexity in our code. And it does that by, obviously, the higher order functions, higher order kinds that you can do in Scala, the type variables that you can parameterize as well, and the mix-in composition. So you can really decompose your system into small chunks of functionality. And then, if you like, you can mix in these small pieces of functionality to arrive at components that are valuable to you. And then, by all means, have these components defined as Spring beans. It's absolutely fine. Everything that you know in Spring still applies. Do you want to use Hibernate in Scala? Fine. Do you want to have the methods in your Scala service transactional? That's fine too. You can use load time weaving, compile time weaving. Everything works just as you would expect. But hopefully, with Scala, you'll end up writing better code with fewer lines of code, which is all that matters. So, what to do now? Follow me on Twitter if you like for the various ramblings on Scala and Spring. The source code for this talk is here. This repository, it includes much, much more. So if anyone's heard of this functional beast called Monad, it's there as well. But we use it to combine PDF files. So it's used in a typical way. It's a kind of usual business requirement you'd have. Cakesolutions.org is where you can find the documentation and links to Specs to Spring. Have a look, download it. It's all in Maven Central and Sonatype. So again, you can just really easily add it to your Maven dependencies and you're good to go. Follow the blogs if you want. Or again, many more details and new updates to everything that's coming. So I'll take your questions now. Yeah? Native, you mean to native code. There is a talk. Of having LLVM Scala compiler. It's in very, very, very early days. But there is a Scala compiler. There are plans for Scala compiler for LLVM and for .NET. So you really can take your Scala code and hope for the best, and maybe in a couple of years it will compile down to native code and quite possibly to .NET. Okay, well, if that's it, I'll be hanging around in the afternoon, so if you want to talk to me, by all means, just grab me somewhere. And thank you for your attention.